This is a video on a hypothesis test for a mean. The question states, the California poppy has a mean height of 35 centimeters. With fertilizer, will the plant grow taller? 65 poppies planted in fertilized soil grew to a mean height of 37 centimeters. The standard deviation for poppy heights, with or without fertilizer, is 9 centimeters. What can be concluded at the 0.05 level of significance? So to start this out, what we want to do is write down our null hypothesis. The null hypothesis is that the mean height's the same. So in other words, H naught colon mu for population mean is equal to, it's the same as without fertilizer, which is 35. So mu equals 35. And then we find HA, or H1, however you want to call it, HA colon, and then it's going to be mu is greater than 35 because we want to see if the plant grows taller, and taller means a greater than 35 height. So let's write down what's given. In particular, 65 poppies, that's n equals 65. They grew to a mean height of 37. That's the sample mean of the 65 poppies. That's x bar is equal to 37. And then the standard deviation for poppy heights with or without fertilizer. We're talking about all poppy heights, not just the ones we looked at, but all possible poppy heights. Now that's the population standard deviation. And the population standard deviation is 9. So we say sigma population standard deviation equals 9. So now that we have the information we need, we can go to our calculator. Okay, so here's our calculator menu. We want to do a hypothesis test because we had H naught and HA. And it's for mu, that's for a mean. So we find the hypothesis test for a mean, and here we're given statistics. We're not given data. We're not given all the different heights that we surveyed. We're only given the mean and standard deviation and sample size. So that's the hypothesis test for a mean with statistics. So here we know the standard deviation of the population. So I'm going to click on sigma known, and notice now it says sigma, and sigma was equal to 9. So I put a 9 there. X bar was equal to 37. So that's 37. N was equal to 65. So I put 65. And mu naught, that's the right-hand side of the hypothesis. And in this case, our H naught was that mu was equal to 35. So mu naught is 35. Now, our hypothesis, if you remember, HA was that mu was greater than 35. So I click on greater than. And I hit calculate. And here we have it. Our test statistic, which is Z, because our sigma is known, is 1.79, etc. And our p-value is 0.3659, etc., etc., etc. So let's go back and think about how do we answer this question now. Okay, so we had our t was 1.79. Our p-value is 0.04. And I drew a little picture for you. So I drew a normal curve. 1.79, I just popped right there. And with an alpha of 0.05, if you look at the normal distribution and you say, what z value will be such that the probability of being greater than that, because we have greater than, is 0.05, that z value is 1.645. Notice that 1.79 is larger than 1.645. Or another way of saying it is that the area to the right, which is the p-value of this x, is about 0.04, whereas the area to the right of 1.645 is 0.05, because that's our level of significance. And if you're far out here, that means it's very unlikely that it would be here had we been in this situation of mu equals 35. So now we can state our conclusion. If it's really unlikely, you say, mu wasn't 35, mu is greater than 35. So let's take a look. And we can conclude that we reject H naught and accept HA, and that there is statistically significant evidence to state that California's poppies' population mean height is taller than 35 centimeters on average when planted in fertilized soil. And I'm done with the problem. Thank you for watching this video.